Okay, let's dive right into this explainer. I want you to picture a rather unexpected setting for a software engineering discussion. A grand, shadowy Victorian library in London. Sitting there at this massive wooden table is a senior software engineer named Margaret. And she's staring down at a truly terrifying piece of legacy documentation. We're talking a massive stack of printed pages, just covered in 3 different colors of ink. When her junior colleague Timothy comes over and asks if this documentation actually still describes their system, Margaret delivers a line that should honestly send a cold shiver down any developer's spine. She tells him the documentation isn't just wrong. She says it is confidently, precisely, beautifully wrong. Welcome to today's explainer, everyone. Today, we're exploring the secret life of Claude code and how AI is fundamentally changing what is arguably the most universally dreaded software engineering task in existence: writing and maintaining technical documentation. We're going to see how this tool is taking documentation from being this painful, deferred chore and turning it into an incredibly powerful tool for thought. All right, here's our roadmap for today. First, the danger of outdated docs. Then, the drift and the cost. Next, writing docs with Claude code. After that, automating the review process. And finally, proof of complete understanding. Let's get into it. Starting off with Section 1, the danger of outdated docs. Or, as I like to call it, lying with authority. Let's think back to Margaret's stack of heavily annotated pages. This brings up a brilliant realization from junior developer Timothy. He realizes that detailed, outdated documentation is actively dangerous. Think about your own codebase for a second. When a system has absolutely no documentation, you know you're flying blind, right? You tread carefully. But when you stumble upon a beautifully formatted, super detailed document, you trust it, and you might literally waste days building on a foundation that doesn't even exist anymore because the whole system was refactored 2 years ago. As Timothy so perfectly points out, the absence of documentation is at least honest. Outdated documentation, it tricks you. Moving to Section 2, the drift and the cost. Let's look at why perfectly good documentation rots. So the absolutely crucial thing to understand here is how this happens to really smart, perfectly good engineering teams. We call this the drift. It's that phenomenon where your software organically changes and grows over time, but the documentation, it just sits there, totally static. And why does this happen? Well, it's not a mystery. Updating the wiki feels like pure overhead compared to shipping the actual feature. You know how it is? The code works, the tests pass, and updating the docs is always that very last item on the checklist that gets pushed to next week and then forever. If we look at the lifespan of a feature, it tells the whole sad story. On day 1, you write the docs at your absolute peak of understanding. The creator is right there, the decisions are fresh, but by month 6, the system gets tweaked and the doc updates get deferred. By year 2, those original documents are completely forgotten until some poor new developer finds them, trusts them, and goes completely down the wrong rabbit hole. The documentation has crossed the line from a helpful asset to a massive liability. That brings us to Section 3, writing docs with Claude code, and how we actually remove this overhead. Historically, writing good documentation is incredibly expensive. It takes serious discipline to clearly explain something you deeply understand to someone who doesn't. But look at this shift. By dropping the time cost from an agonizing hour of manual drafting down to just 15 minutes of AI-assisted articulation, Claude code practically eliminates our main excuse. You can't really say, "I don't have time anymore." The friction is pretty much gone. The workflow here is brilliantly simple, but the division of labor is what's truly a game changer. Step 1, the thinking and decision-making, that stays entirely with you. You describe the system and its constraints. But step 2 is where the magic happens. Claude actually pushes back and asks you the missing questions. It spots the crucial context that a brand new dev would need, context you probably skipped because it felt too obvious. Finally, step 3, Claude handles all the tedious mechanical articulation. It just structures your thoughts into a clean, clear document. All right, Section 4, automating the review process, or asking if it's still true. How does this work for legacy systems? So writing new docs is fantastic, but what about Margaret's stack of outdated, heavily inked pages? Well, instead of a senior dev burning 2 whole days manually cross-referencing old docs against new code, Claude code takes over that mechanical pass. It instantly scans for changed function signatures, missing parameters, and replaced workflows. This elevates you, the human, entirely to the judgment side of the table. You become an editor. You just have to look at it and ask, do these discrepancies actually matter? What needs a quick update, and what should we just retire? And the time savings, they are absolutely staggering. It compresses what used to be a half day or even multiple days of mind-numbing cross-referencing into a handful of minutes. Actually, scratch that. It changes the entire dynamic. When a first pass only takes a few minutes, you're actually willing to do the review in the first place. Let's hit Section 5, Proof of Complete Understanding. We are reframing documentation as a thinking tool. Margaret hits on a really timeless truth here. If you cannot explain a decision to Claude, it's a massive, glaring red flag that you don't fully understand it yourself. Much like writing a unit test, documentation is a rigorous test of your own logic. See, your code can easily hide a lack of deep understanding, but documentation cannot, because you are forced to explain the why. If a decision is undocumented, it literally cannot be defended. So we need proximity, updating docs in the exact same sitting as the code. And we need ownership, realizing the docs are the work, not just a byproduct of it. So, as we bring these AI tools into our daily flow to drop the friction to zero, we really have to ask ourselves, how do we keep it true? How do we build the right habits so that the drift doesn't just happen all over again? Timothy has this amazing epiphany that perfectly captures the new standard we should all adopt. He says documentation isn't the record of the work, it's the proof that the work was understood. This means it's no longer just a virtuous chore you can brush off. If a system works but you can't explain it, your job is only half done. The explanation is the definitive proof that your engineering thought process is actually finished. And hey, when you are dealing with legacy documentation that has just drifted way, way too far from reality, Margaret gives some incredibly freeing advice. The kindest, most efficient thing you can do for yourself and your team is to just acknowledge the lie. Retire the old documents entirely. Let them go, use AI to start with a clean page, and build better habits this time around. As we wrap up this explainer, I really want you to think about your own repository. Think about the code you're going to pull tomorrow morning. What beautifully written, perfectly formatted lies might be waiting in there to trap your junior developers? What complex decisions have you shipped where you haven't yet proven you fully understand the why? It might just be time to fire up Claude Code and start a clean page. Thanks so much for joining me today, and keep learning.